Imagine gazing up at a familiar night sky, the comforting glow of the full moon illuminating the darkness, a steadfast companion since the dawn of humanity. The moon's silvery light has inspired countless legends, guided explorers across seas, and regulated the rise and fall of tides. Yet, imagine for a moment an alternate future, one where the moon is not a passive bystander to Earth's story, but an unstoppable harbinger of cosmic disaster. What would unfold if, against all odds, the moon's orbit decayed, and it began a fatal descent toward collision with our planet? Let us journey through this ultimate nightmare scenario, exploring not just the resounding cataclysm of the impact, but also the subtle, cascading consequences leading up to, and following, the unthinkable. To begin, we must understand the moon's current relationship with Earth. Our moon is locked in a delicate gravitational dance, orbiting roughly 384,400 kilometers away from us. Its presence stabilizes Earth's axial tilt, giving rise to our seasons. Equally important, the moon's gravity tugs at the world's oceans, generating tidal cycles that have nurtured life for eons. But this balance is not immutable. For our scenario, let us picture a sudden cosmic anomaly. Perhaps a rogue planet sweeps dangerously close, or an enormous asteroid disturbs the moon's velocity, yanking it irreversibly from its stable orbit. As the moon's orbital path begins to decay, it spirals ever closer to Earth. The first sign of trouble would not be devastation, but awe-inspiring, unsettling beauty. The moon's apparent size in the night sky would swell night after night, growing larger and brighter. Ancient myths would pale in comparison to the reality now looming visibly above. But this new moon would bring more than spectacle. Its growing proximity would have profound effects on our tides. Even before collision is imminent, tidal forces would increase dramatically. High tides would rise ever higher, flooding coastal cities, eroding beaches, and transforming river estuaries. Low tides would plunge lower than ever before, exposing reefs and disrupting delicate marine ecosystems. The tides that once marked time would become irresistible floods, a warning of greater disaster to come. As days pass and the moon continues its inescapable approach, the devastation intensifies. Tidal forces are not limited to drawing oceans. They exert stress on the Earth's crust itself. Approaching what scientists term the Roche limit, the minimum distance where a celestial body held together only by gravity will start to break up, the moon's structure would deform. Cracks might appear on its surface, massive landslides and moonquakes shaking loose ancient regolith. Simultaneously, solid ground here on Earth would begin to heave, pulled by unprecedented gravitational stress. Fault lines might rupture, triggering earthquakes in unexpected places, fracturing mountain ranges, and sending tsunamis racing across the seas. Humanity, of course, would scramble to respond. Emergency warnings would blare, evacuation plans enacted in every coastal region worldwide. Cities like New York, Shanghai, and Mumbai would become ghost towns as massive waves swallowed shorelines. In low-lying countries, millions would become climate refugees almost overnight, forced inland as their homelands vanish beneath surging tides. The growling of tectonic plates would not be the only sound of imminent doom. The atmosphere itself would begin to change. As the moon's gravitational field tugs ever harder on our planet, atmospheric tides, normally minuscule compared to oceanic ones, would become violent, disrupting wind patterns and unleashing extreme weather. Hurricanes, cyclones, and tornadoes would sweep across continents, the sky tearing itself apart under invisible gravitational stress. In the final days before the impact, the moon would move into the Roche limit, a boundary approximately 9,500 kilometers from Earth's center. Here, the moon's fate is sealed. Tidal forces exceed its own structural integrity, and the lunar sphere would start to come apart. At first, this might appear as mountains of dust and rock ejected from lunar craters, forming a shimmering, deadly halo. As the disintegration continues, large chunks of the moon, ranging from boulder-sized fragments to city-sized slabs, rain down upon the Earth at colossal speeds. These lunar impacts would devastate the biosphere. Each fragment crashing on Earth would release the energy of a nuclear bomb, smashing craters into continents, flinging